Hi everyone, my name is Hajun Chen and I am from the Large Language Model on the Edge team from the 2025 capstone. Today I want to share you on how to use HPC. So let's first learn about what is HPC. HPC is a high-performing computing system that maintained by the College of Engineers for the purpose of research and classes use. It contains multiple high-end GPUs, CPUs, and a lot of RAM for memory. For example, we have H100 GPUs in one of the node, which is a top performing computing resource during the time. And all of the College of Engineers students will have access to this cluster. All we need to do is to activate it and know how to use it. So before we want to use a HPC, you have to activate your HPC account. So for College of Engineers student, you want to go to Teach and click on the high performance computing here. And then after you will see your HPC account info. And then if you're not yet activate, you should see something that prompts you to activate. You can just click create here. So this is the Teach website, and then I will walk you through the HPC activation. So first you want to log in here. Then we can see on the right side here, here's a high performance computing tab here. So what you want to do is click on here. So for me, I already create and are ready to use. If you're not yet created, you should see something similar to the image so before, and you can just click create. Now let's learn how to log in and use the HPC. First, let's learn some very important terms. The first one is submit server. It's a login and job submission node that will handle all users' requests to the HPC. The next is slurm. It's a resource and workload manager for the HPC. It will handle all tasks like job submission or job status lookup. Now we have two major ways to use the HPC. The first is SH into the submit server and use slurm. The pro of this is that you can submit multiple jobs for experiment-like tasks. Next, we can use on-demand interactive desktop. You will open a GUI and able to use it like a general computer. It's good when you need to run interactive application using the GPU in HPC. I will demonstrate both way to you and you will get a better understanding in the later demonstration. So let's now learn how to access into submit and use Learn. The first thing you want to make sure is you are either physically in Oregon State and using the school internet, or you are using the VPN of our school. This way will ensure you can connect to any of our school server. Then you want to have some sort of terminal ready. You can either use mobile external like I do here, or you can use any terminal you like. Okay, the next thing you want to do is to SSH into the submit server using this command. It's very simple. It's just SSH and then your ONID here. This is mine. You want to replace this with your own ONID and then add the region name of the submit server. And then you press enter. And like mine, you probably have some problem for your password. Just enter your password here like you will enter for a flip server. So the first thing you want to do after you get connected to the submit server is to load slurm. So it's very simple as well. You just type module row slurm. Very straightforward. So if you want to check if it got rolled successfully or not, you can type in module list here. This will tell you what kind of module you have currently loaded. Now let's learn how to create a batch file so you can submit the job. The first one you want to have is some sort of executable file you want to run in the HPC. So for example, here I have this Python file that I want to run for demonstration, and then it will just add up two random numbers together and print out the result. Next, you need to have some sort of batch file ready. this batch file will be submitted through slurm from the submit server to the HPC. So one of the node will take care of this job. So let's learn about this batch script. So the first line here tells the system this runs on batch shell. Then for all this S batch with a hashtag is the slurm directive. They provide instruction to the job scheduler. For example here, this tells the slurm what name do you want to give this job is. Then in here is the name of your sponsor account. It can be a class or research group, but if you don't have that, it's okay. You can use the ECS for general students. Then we have the name of the partition or queue here. So different partition will have different resource to use. For example, different type of GPU or how much memory they can have. So for different tasks, you want to choose different partition. I will show you a list of partition that general student can use later. Then for the -o is the name of the output file for this submitted script. And then for -e is the error file for the submission script. And then for this one is saying that we want to grab one GPU to run this script. You can increase the number of GPU you want, maybe even up to the limit of the current partition. But as you increase the GPU, it will be harder for you to get in the queue because there are many people are using the partition as well. So be wise when you choose the number of GPU you want. And then after all these directives, you can move on to running executable command. For example, here I start with running this NVIDIA SMI, which will tell you what kind of setting of GPU you have right now. Then I run my jobs. Here, just I will run on a regular terminal. I run Python hello.py, and this will execute the job here. So now we are ready to submit the job. So all you need to do is type S batch and the name of the batch file. So for me, it's sbatch hello.sh. And then you can see the job is already submitted. And if you want to find a job that's running currently, you can type in sq-u and then your ONID. You can see the job we just submitted here, ending with 946, is running here in the node of DGX2. So if we wait a second, that after it's done, and then we can see again, now it's done, and then it's not running anymore. This is the another job I'm running. And then you can see we have an error file and then output file. So for the error file, I expect nothing here since there's nothing went wrong with the job I submitted. For the output file, I expect it have the output of the executable command we put in. So for here, this is the output of the NVIDIA SMI. So as can be seen here, in this node, we have one V100 GPU for us to use. Then this is the output of the Python file I wrote. Now let's learn the second math we mentioned before, which is using the on-demand interactive desktop. As always, the first thing you want to make sure is that you are in Oregon State using the Wi-Fi or you are using the VPN here. Then you want to access this website here. Well, the most easy way to you to find this is you search Oregon State University HPC here, and then you go to the homepage. Then you want to go to optimize your HPC environment. Then HPC portal. This is the exact link I show here, and then you by clicking on here, you don't need to type this on your browser. So let it take some time. So as can be seen here, the website is still submit server. So you are still using a submit server, but with a website form. So right here, you enter your ONID and the password here. It's the same thing as the flip server or your email login. So you want to click login to open demand. Given now that we are on the open demand portal, I want to show you some feature in here. So the first thing is this file management system. So it's the same file you see when you log into your flip servers or the submit server. and then you can manage all your file here in your website. Then you can see the job you are running right now. This is a job I run for the interactive desktop that I will show you later. Then you can access the shell here as well. Just shell here, and then don't need to use mobile external or VS Code shell. It will automatically connect to another submit server. And the other thing I show you in the first math can be done in this shell as well. Then the next thing, the most important thing, is this interactive application. So I want to show you how to activate a desktop here. So if we choose the Advanced College of Engineering HPC desktop, you have a bunch of different settings you can see. You can choose what kind of partition queue you want. So right now we have this much partition, and then we will choose DGX2 here because it's one of the most easy to access, but still have some good GPU to use. And then you can type how much hour you want to reserve this. The default is 12 hour, but you can reserve up to 168 hour. And then you can see there's all other setting here for you to choose. And then after you have the desired setting, you can create launch here. And this will send a request to the HPC for your College of Engineer desktop. And then I already have one running here, so let's see what's inside. Oh, as you can see, it's already give me the desktop here. So let's get into the desktop right now. So usually you need to enter the password for the desktop. It's the same password you will use to log into Flip server or your email. So we unlock it, and then this is just like a regular computer you will use day by day. It can do all kind of things you want. For example, you have web browser here. I think the default here is Firefox, and then you can have file manager. This is the directory you will have when you log into Flip or Submit. And then also the most important thing for us probably this VS Code here. So it comes default with VS Code, and then you can open any folder you have in your directory. So I want to open the folder I created uh, in the math one to show you. So HPC test here. So as can we see, we have this Python here. Uh, I show you in the last math. So if you want to run this, we can just open the terminal here, and then you can just run your Python hello.py here. And then, oh, there's a time slip. I'm going to take it away so we don't have to wait. So let's run this. So as you can see, it's running pretty fast here. And then we can also see what kind of GPU we have currently. So NVIDIA SMI. So we are having another V100 since we are in the DJX2. All of it is V100. So this is the desktop, interactive desktop. You can do any kind of job here. The most useful thing probably is you want to run something interactive and it requires a lot of GPU computing resource. So by now you should familiar with how to use the HPC. And then you probably will have more questions during the time when you use. By the time you run into some problem, I highly recommend you take some time to read this HPC website here by College of Engineer. It have bunch of documentation you needed, and it's very easy to have. So, for example, if you have a question, you can probably find answer here in the FAQ here. So, there are bunch of questions related to general questions, some questions, software question, and data storage question. So if you have question, refer to this website as well. As I promised in the earlier of the video, I will show you the hardware list that the general student can use. So If you want to know what kind of GPU in each node, you also need to access the HPC webpage, and then you click on the About the cluster, which will take you to this page, and you can find the hardware information here. For example, for the DJX2 we use, we have 16 NVIDIA Tesla V100 in this node. So that's why we will always get V100 when we type NVIDIA SMI here. So for undergraduate students like us, the node we can access here is limited. So we can use the share class DGX2, DGXH GPU, and then the Ampere, and then the EECS series. Then we also have the preempt. So all of other is either from the research group or any other specific classes. So stick with this node will get you a faster access. And then this will be the end of our tutorial video. I believe you will run into issue when you use HPC like I do in the very beginning. So when it comes to this moment, take some time and read the documentation here in the College of Engineer HPC homepage. I believe you will find the answer, and I hope this video can get you a great start in your project. Thank you for watching.